Right, so recording is on. And now we can, and this one is kind of interesting, if you just look up a paintball, Sentry, the guy basically hooked up a webcam to a desktop computer, to a laptop computer, and then from the laptop computer he runs some kind of special hardware to control servo motors, and then the whole purpose is to track a moving object, from the webcam's perspective, and shoot paintballs at that object, and make the whole system automatic. You don't have to point, click, or do anything. It's fully automated. He got it well. The design is good enough that it can track a bouncing basketball that is bouncing across a patio. And at the end of the sequence, you can see the basketball actually got painted a few times. So it's actually pretty good. I mean, that's not easy. You can give a paintball gun to someone, the actual person, with no experience, shooting it. It's hard to, hit something like that. It's bouncing and it's moving at the same time. So, kind of interesting stuff. All right. So this is the website to the Computer Science Club. You just have to go to the Power server, power.arc.losreals.edu/Drupal7, because that's what they're using for the website. I'm gonna have a link at the homepage too, but I haven't gotten around to do it yet. So I'm gonna close this. This one is just it's on the WordPress part of the Power server. Just attach a WP at the end of the Power server URL, and it's about, this one is about pointing devices. Yep. Go ahead.
I've got Pi, but I don't know how to use it. Like, when I take here, we could do some projects with it, or?
Sorry?
A Pi? Raspberry Pi?
A Raspberry Pi?
Yeah, I'm about to do one.
Okay, a Raspberry Pi is essentially a single board computer that has an ARM processor on it. It has enough RAM, it has enough processing power to run Linux. So once you can put Linux onto a Raspberry Pi, then whatever you can do with a regular installation of Linux, like what I'm doing here, you can do it on the Raspberry Pi. So you can use it for networking purposes, use it as a router, you can use it as a gateway, you can use it as a bridge if you want to, bridge between Wi-Fi and wired networking. You can also use it to control other things, because it has the ability to expand, in that direction. It also has HDMI, connection, so you can turn it into an in-car, entertainment, system if you want to.
So they're more like along like drone probably. What's good for it?
For what?
Like a drone project.
General project?
Like a drone?
A drone?
Yeah.
It might be a little bit too heavy, so you need a drone with more carrying capacity for something that big. All right. So last time, we talked about logical versus bitwise, operator, and what Danny just demonstrated is a good example of why bitwise operators are useful. Okay, because when you are dealing with a circuit board like that, with the Arduino board, each pin on the circuit board, on the outer part of the circuit board, is controlled by 1 bit of one input-output register. So to turn on something, you just want to change 1 bit of one particular quote-unquote variable. So how do you, turn on just 1 bit or turn off 1 bit of a particular variable? Say again? Right. But how do you make it? How do you make that happen? Because remember, on Monday we talked about an integer usually has 32 or 16 bits, right? So those are 16 individual binary digits. The question is, out of the 16 or 32 binary digits, if I just want to change one of them and turn it into a 0 or turn it into a 1, what do you do to get it done? If an OR statement can detect something, but how do you change it? Okay, I'll give you an example. Okay, this is probably a good place to show you an example. So I'm going to use mousepad to show you an example. let's just look at 8 bits. Okay, so instead of using a 16-bit integer, let's just look at 8-bit integers because otherwise it's just a lot longer unnecessarily. Okay, so we'll take a look at an 8-bit integer. Let's say it is 135. Okay, in base 10 as an 8-bit integer. Okay, and what we want to do is to turn on enable bit 3, and we want to turn off disable let's say bit 5 here. That's what we want to do. How do we get it done? Well, the first thing we need to do is to figure out, okay, with the value 135 in base 10, what does it look like in binary? That's the first thing we need to do, because unless we do that, we cannot visualize which bit are we dealing with, and as a result, we wouldn't be able to tell how to get it done. Okay, so how do you convert 135 to a base 2 number? Remember from Monday's discussion, the first thing you do is to think in powers of 2, starting with the larger powers of 2. So you look at 135 and you say, well, what is the largest power of 2 that is less than or equal to 135? 128, right? So you say 135 is 128 plus 7 in this case, right? 7, yep. And you look at the 7, you ask 4 plus 2 plus 1. Okay, so I'm combining a few steps into one. But when you look at 128, 4, 2, and 1, they are all powers of 2. Okay, if you cannot do it in one single step, that's okay. Just take a few more steps. But eventually, we want to end up with a sum of powers of 2. Once you turn it into a sum of powers of 2, the next step is to re-express 128 as a power of 2. All right, well, that's easy. 128 is 2 to the power of 7. 4 is 2 to the power of 2. 2 is 2 to the power of 1. And 1 is 2 to the power of 0. And once you have these powers of 2, then you can start to represent each one as a binary number. As a binary number, 2 to the power of 7 is 1 followed by 7 zeros. Okay, the power itself indicates how many zeros you need to pad on the right hand side. Or if it is negative, it indicates its place on the right hand side of the point as a quote unquote binary point number. But in this case, as a whole number is an integer, so we just have to say this is 1 followed by 7 zeros. It's a base 2 number, plus 1 followed by 2 zeros as a base 2 number, plus 1 0 as a base 2 number, plus 1. Because the last one is 2 to the power of 0, which means it has no 0 to the right hand side. Once we have everything expressed as a base 2 number, the next step is to line them up so that we can perform the actual addition in base 2. But in this case, addition in base 2 is pretty easy because a column can either have something or not have something. So that makes the addition pretty easy to do. There's no carry in this case. So once you add up everything, then we get the actual bit pattern. The actual bit pattern is 1 0 0 0 0 1 1 1 in base 2. This is a quick review of what we talked about on Monday. Okay, we did this already on Monday, and it's good to be able to do it again. This part you can do it with a calculator. Okay, from base 10 to base 2, most calculators can do it. But it is important to understand how to do it by hand because it really is a basic knowledge of what a number really is and how to change the base, okay, or how a value is represented in different bases. Okay, so now that we have a binary representation, let's get back to what we actually wanted to do with it. We want to enable bit 3 and disable bit 5. I'm going to change this problem here because the bit pattern actually already had these bits set. The one that I want to turn on is on already. The one I want to turn off is off already. So that wouldn't be too much fun. So let's go ahead and change the problem to turning on bit 5, changing it to a 1, and turning off bit 3, turning it into a 0. Okay, how do we number the bits? This is bit 0. Yep.
How do you know that it's already on or off?
Because I can see it. Actually, I take it back. This one is off already. So let's go ahead and pick one that is already on. Let's pick bit 2. Okay, because I can count the bits. This is bit 0. So bit 0 is a 1 already. It is on already. This is bit 1. It is on already. This is bit 2. It is already on. So I want to turn it off. This is bit 3. Bit 4, bit 5, it is off at this point. I want to turn it on. I want to turn that one into a 1, but without affecting the other bits. That is the key. Okay, I don't want to change any other bits except for bit 5 in the first operation and bit 2 in the second operation. Okay, so we'll focus on one at a time. Okay, so what we'll do is we'll look at the bit pattern that we have at this point. And then we'll identify the bit that we want to enable, which is bit 5. So bit 5 is actually this one here. So I want the result to be 101, 00, 111. And this is the one thing that I want to turn on. So the question is, what bitwise operation allows me to do that? I'm not looking at arithmetic operations. I don't want to do subtraction or addition. I want to do a bitwise operation. A bitwise OR, exactly. So we want to perform a bitwise OR operation. So we'll specify the bitwise OR operation, which is a single bar, and then turn all of the other bits to zeros. Just to be sure that we specify all that stuff. And that will turn on that one bit without changing any of the other bits. Yep.
What is that? Just a straight line?
Yep, it is the straight line, which is shift backslash on the keyboard.
Okay.
Yep. All right. Well, that's good. This is 135, and we get back whatever result we are getting back here. But what is this number here? What are we doing a bitwise OR with 135? Well, you just have to count the number of zeros, right? This is 1, 2, 4, 8, 16. This is 32. So that means, if you do a bitwise OR with 32, then bit 5 is guaranteed to turn on without affecting any of the other bits. Then you can say, well, but adding 32 would do the same thing. Well, adding 32 would do the same thing in this particular case because bit 5 was originally off. But what if bit 5 was already on originally? Then adding 32 to it is going to affect the other bits. But doing bitwise OR does not change any of the other bits. If it's already on, it would just stay on. Nothing happens to it. Yep.
Where's the bottom came from? The 001000.
You mean here?
The one before that.
You mean this one?
Yes.
This is the bit pattern that we need to specify to perform the bitwise OR to turn on bit 5. To change bit 5 to a 1. It is also known as a bit mask because it has one single bit turned on, and usually we refer to that as a bit mask. Yep.
So you got the 32 because that's considered 2 to the 5th power.
Yes, because there are 5 zeros in this binary number, and as a result, it is representing what we know as 32 in base 10. All right. Any questions about why we choose to use the bitwise OR operation in this case to turn a bit into a 1?
Can we use logical in this one?
Sorry?
Can we use logical? Or you have to
No, a logical OR would not work at all because remember, if you do a logical OR, okay, let's go back and take a look at the logical OR operation. From the lecture on Monday, can anyone remember how I should specify the result of 135 logical OR 32? 135 is non-zero, 32 is non-zero. So non-zero logical or non-zero is can be anything that is non-zero. Okay. So this is telling me that I should remind you guys to kind of review the notes, and things that we have talked about in the previous class, because the further it gets, the further you have to rely on things that we have talked about already. Okay, so you got to make sure that you understand all the concepts in the previous class, because all the new stuff kind of build up upon the older stuff that we have talked about. Right, so that's not going to work. We have to use a bitwise OR operation in this case. Addition is not going to work, because with an addition, if the bit is already on originally, it will change the other bits, which is not what we want to do. We only want to change one bit. How do we turn something off? Okay, if a bit is already a 1, I want to turn it into 0, what should we do?
Bitwise AND.
Yep, bitwise AND is the answer, but the question is, what are we going to AND it with? So in this case, I want to disable or turn bit 2 into a 0. Bit 2 is this one here. So what should I specify as in the second row so that the result is 101 0 0 0 1 1, because this bit is changed from a 1 to a 0. I don't want the operation to change any of the other bits. So what should I do here? How can I preserve this 1? I can either do an AND 1, right? 1 AND 1 is 1, but then with an AND operation, I can also change something to a 0. So I can do an AND 1 here. How do I preserve a 0? AND 1 will do it too, right? AND 1 will preserve a 1 or a 0. So I can turn all of these into 1s. All the ones that I want to preserve, I want to specify 1s. And with the one that I want to turn off, the one that I want to change to a 0, even if it was originally a 0, it would just preserve the 0. I'll put the 0 here. And then the operation itself is a bitwise AND operation. So a bitwise AND operation is useful if you want to turn a bit into a 0. If it was a 0 already, preserve it, okay? Don't change it. If it was originally a 1, turn it into a 0. A bitwise AND is useful for that purpose. If you want to turn a 0 into a 1 or change anything into a 1, then you want to use a bitwise OR operation. Now these are very important in the demonstration that Danny did earlier, because on a controller like that, you have control over each individual bit of what we call a port. Okay, a port has 8 bits, and then each bit can connect to a different thing on the circuit board. So most often, you want to turn off one and turn on the other one without affecting the other bits. And this is how things are done on those controllers. Are there any questions about the mechanism, how we actually did it, the math of it, or the rationale of doing this?
So, you have 135 and 3200. Is there like a equals to something after that?
Well, you look at the result here, and it is 1 plus 2 plus 4, and then plus 32, and then plus 128. So if you look at the actual decimal value, it is 167 as an unsigned integer.
So one adds and the other one subtracts.
Yeah, but I don't want to think in adding and subtraction, because if this bit was a 1 already, it will still be a 1 here without affecting the other bits. In other words, if you use 167 as the top number, and then you do a bitwise OR of 32 with 167, you end up with 167. It does not change the value, because it's turning a 0 into a 1, but if it was a 1 already, it doesn't do a single thing. So that's why I did not want to use an addition. I want to use a bitwise OR, so that the other bits do not get changed. All right. Any questions? Yep.
Can you go over how you disable bit 2 again?
To disable a bit, you use the bitwise AND operation. So in this case, if you look at the truth table of bitwise AND, 1 and 1 is a 1. 0 and 1 is a 0. And then we get all the way here, we have a 1 and 0 becomes a 0. Okay, any other questions? And I know someone is going to say, but I'm not going to program those robotic stuff, ever in my career, even though it's going to be, the most important thing, one of the most important things in the near future. I don't want to touch that. I just want to do database programming, okay? Or I want to do some application programming that does not involve, controlling motors or LEDs or devices and stuff like that. Well, bitwise operation is still useful in those cases. Think about it. If you have something to store and the value that you really want to store is true false, okay? Let's say it is a field from a form, okay? Can anyone name or give me an example of a field in a regular form that you have to fill in that's either a yes, no answer or true false answer?
Sex.
Gender?
Yeah.
Well, that's actually no longer a true value thing.
Okay.
Yeah.
Yeah, you're right.
Yep. So they have now either not asked that question at all, or when they do ask that question, sometimes they have 4 choices. It will be male, female, not want to specify, or other.
Okay.
Yep. So that's why that's not a good example.
Not anymore.
Yeah.
You get you're being convicted of a misdemeanor felon.
Okay, yeah, that's one. You can also have something like there's something that is completely benign, like do you want to have a parking permit for this semester, right? So in that case, it's either yes or no. I would like to purchase a parking permit for this semester, or I do not. Okay, how many bits do you need in order to store an answer like that? 1 bit, right? Because it's either no, you can use a 0 to represent it, or 1 to represent yes, I do want to, purchase a parking permit for this semester. But when you use a regular variable, okay, how do you store that answer? There are several ways, okay? In C++, in C, if you do not use all the tricks that we will talk about, you can use an integer, okay? A 0 for the integer means no, and a non-zero value means yes, okay? But that's a waste of storage, because an integer is at least 16-bit wide, and you're using up 16 bits in order to store something that can store in a single bit. But that's okay. We have gigabytes of RAM and we have terabytes of hard drive space, so it's okay. Well, that may be the case on a regular device, but when you're dealing with, let's say, a Raspberry Pi, or the Arduino, or some of those controllers with limited resources, you really want to pack as much information into as little space as possible. Okay, so how can you do something like that? How can you store something that's just yes, no with a single bit, when the programming language only has integers and characters as the smallest unit for variables? What we have just talked about, right? This allows you to store and retrieve information on a bit-by-bit basis instead of on a integer-by-integer or char-by-char basis. Okay. To most people, it is a non-issue just because we have so much resources these days on regular computers. But in certain cases, it is not the case. You really have to think hard to pack all the stuff into a very small amount of RAM. Yep.
So in case of switching something on or off, we only use the AND statement, or
you use the AND to turn something into a 0. You use the OR to turn something into a 1. The AND is also used to check whether a bit is a 0 or a 1. Okay, because if you do a bitwise AND, with okay. So let me give you another example here. So the other example is is bit 6 of 1 or 0? That's the question. In other words, I'm not trying to change it. I'm not trying to change it to a 1 or 0. I just want to know, is it a 1 or 0? Because I have a conditional statement. If it's a 1, I want it to go this way. If it's a 0, I want it to go the other way. How do I do it? Well, it's a combination of what we have just done earlier. Okay, so the expression that you want to do, or the statement that you want to do, is to say, if x, which has the bit pattern, and then you want to specify a bitwise AND, and then you specify, bit 6 all by itself. Now, bit 6 means it is a 1 followed by 6 zeros in base 2, which is 64 as a value. Then you can specify the then branch as well as the else branch. So this is the then branch, which means bit 6 is a 1, and this is the else branch, which is bit 6 is a 0. So this conditional statement, using x as a variable to store all the bits, and using the bitwise AND operation to check only one bit to see whether it's a 0 or not, will help you decide which way to go, depending on whether bit 6 is a 1 or a 0. So are there any questions about this code here? Not so much the syntax, we'll talk about the syntax of a conditional statement later, but is it okay? I mean, I haven't really talked about the syntax of a conditional statement, but does everybody still understand the meaning of the conditional statement? I'm not asking you to write one, I'm just asking you to understand what I have written. So it's still clear, right? Okay. Yep.
The question, for example, in the bitwise OR pattern, if you were to flip that sign to an AND, would all those become zeros except for the one that you had?
Yes. Yep. Because anything and 0 is a 0. But anything or a 1 is anything. How many people caught what I just said? A few? Okay, so that means I should say it again. Okay, so the thing is, anything and 0 is a 0. Which is kind of like multiplying 0, always get you 0, okay? But then anything and 1, at a bitwise AND, I should specify that, bitwise. Anything bitwise AND 1 is a 1. And then we can say something similar for disjunction. Oops, sorry, I take it back. It's the identity, okay? 1 is the identity of conjunction. If you have a value x, and then you do a bitwise AND 1 with it, you always get the original value back. It's just like x times 1 is x, regardless of what x is. OR has something like that. So if you have a x bitwise OR 0, you always get back x. It's just like x plus 0 is always x in addition. X bitwise OR 1 is always 1. Is that making any sense? Because 0 bitwise OR 0, 0 bitwise OR 1 is a 1, and then 1 bitwise OR 1 is also a 1. So these are useful because I make use of these in order to preserve the other bits. Are there any questions regarding bitwise operations? Yep.
So I don't really understand why it's bit x and 64. I don't really understand why it's bit x and 64.
Because 64 is 1000000 in base 2. So in other words, only the bit that I'm interested in is a 1 that I'm doing a bitwise AND with. So the result of the bitwise AND will either be 64 itself or 0. And because in C and C++, if the expression is non-zero, it is the same thing as a true. And if the expression is a 0, it is considered the same as a false. So that's why this works. In other words, if you look at this, from the perspective of, that is kind of odd, you can just kind of say, it's actually, it means the same thing as this. And this is, by the way, not equal to. I think we talked about not equal to already. Did we talk about not equal to, the comparison operators? I think we did, yep. All right. So are there any questions related to bitwise operations? No questions? Is anyone still kind of convinced that you will never need to do bitwise operations? There are usually a few people, who think, bitwise operations are not for real programmers. They're for low-level programs, but not for me. And by the way, what is the smallest environment you can write programs in? Well, not exactly a byte. I mean, including the space to store a program. 8 bytes. That would be like a little bit too much, too small. Even for tiny devices. Well, let's take a look. I want to show you this, because I want to convince you guys that there are platforms where you have to write programs in a very, very compact way. And the part number is AT-tiny. We'll look up microcontrollers. And we'll go ahead and look at it here. All right, so at this point, I'll show you the specifications. A microcontroller is a single chip that has everything that you need to run the program. So it has storage for the program itself. It also has storage for your variable. At the same time, it has all the circuitry that you need to control the output of a pin or to sense the input of a pin. So these things are suitable for what we call embedded system control, where you have a switch. Someone can press a switch, and you want it to actuate, turn on something, or do something similar to that, automation stuff. Okay. So with this, I'm showing you a particular part. The processor runs at either 10 or 12 megahertz. These are filters to find a part, okay? 10 megahertz, I mean, what was the last time you go to Fry's and see a processor running at 10 megahertz? Let's see, about 30 years ago. Okay? 30 years ago, we had, the 8086 processor and also the 8286 processor running at about 10 to 12 megahertz. Okay, I'm not going to talk about what is an ADAC, at this point, but I do want to point out the other parts here. This is the packaging available for the part. SOT23 is very small. Just look at your fingernail on your pinky. Okay, I know some people have larger and some people have smaller fingernails, but on the average, I would say you can fit 6 or 8 of these chips on your fingernail of your pinky. Yeah, they're small, they're tiny. Okay, in fact, soldering these things require special skills because it's not a through-hole part; it's a surface mount part. Okay. If you're soldering these things and you sneeze on the circuit board, the components will fly away. And I'm not kidding because I do it on a regular basis. Not the sneezing part, but the soldering part. So when I'm soldering these things, I make sure that I don't blow anything on it, because they're really small. The other one is even smaller, but it's for a special purpose. Okay. So the next question is, well, what is the whole point? This is what it looks like, but it's magnified, a great deal, and then it looks like this, okay? But what we want to see is, some other stuff, related to it. For instance, how much is one of these things? If you order 4,500 at a time, it is 39 cents. Call it 40 cents. If you take 4 dimes and walk into the bookstore, what can you buy? Exactly. It's 40 cents will get you a chip like this. Even though it looks really simple, it doesn't seem to do a whole lot. It has a processor in it. It has flash, to store a program, and it has RAM for variables. It even has a built-in oscillator, so you don't need an external clock. For those of you who know what a clock is, it only takes 0, the ground, and also I think 3.3 volts to run, and then you can use it to control stuff. Okay, the size is tiny, but you have to pay something for all of this stuff here. It is inexpensive. What you're paying for, or your price, is the program space is 256 by 16. What does that mean? Does it mean that it's 256 kilobytes or megabytes by 16 banks or something like that? No, it is 256 as in 256 by 16 bits. So your program space, your entire program, has to fit in 512 bytes. Yep.
Going back to the unit cost,
Yeah.
it was about 40 cents.
Yeah.
But you have to buy 4,500 of them at
Yeah.
that price, right?
Yeah.
It's about $2,000.
Right.
$1,500.
Yeah, you have to shell out $2,000 to stock up 4,500 of these things. But if your invention, what you're using these things in, is like a Furby or a toy like that, you'll be buying hundreds of thousands of units at a time, which means your price will go even lower. Okay, it's not going to be 40 cents. It's probably closer to 30 cents or even less. Okay, but what you need to do is to write programs that will fit into a tiny little space, because your entire program can only have up to 256 instructions, and I'm talking about assembly language instructions, not lines of C++ code. Okay, and then on top of that, another restriction is how much RAM you have. Okay, how many variables can I store? 32 by 8. What does that mean? 32 by 8 bits. 32 bytes. That's all. You have 32 bytes to store everything that you need in this program. And the program itself can only have 256 assembly language instructions, which is not really a whole lot. Okay? But the reason why you might end up with a job like that is because the part is so inexpensive. You can put it into devices that are also inexpensive to begin with. Okay, you're putting 40 cents of parts into something, let's say, has a cost of, say, 20 or 30 bucks. It will still be doable, right? What type of devices are we talking about? What type of application are we talking about?
Kids' toys.
Toys would be one, okay? RC helicopters, that require certain types of control mechanism, can certainly utilize processors of this kind. What else? Well, that particular robot actually takes a little bit more logic than this chip can support. When was the last time you see a torque wrench? Does anyone work on cars or mechanical stuff? Some of you? Okay, so you know what a torque wrench is? A torque wrench is basically just a wrench, except it has the old traditional type has a click. Okay,
Yeah.
so if you apply up to a certain amount of click, it will of torque, it will click to let you know, okay, don't torque it anymore because you're going to strip the nut or something like that, right? But torque wrenches now have digital interfaces.
I wouldn't trust that.
Oh, but if it's made by Snap-on, you better trust them.
Yeah.
When it goes
Yeah.
when it goes out of whack, how do you put it back to like on an electrical, on a mechanical one, you can set it back to 0.
This one you use a digital interface. There are buttons on the thing to set the torque, and then it beeps you when it's done, when you have reached that amount of torque.
No, I mean like when you use it too much and then it starts to overlap, it starts to become out of whack, out of like.
But with an electronic device, it doesn't get out of whack. It uses what we call a no, it's a what is the name of that thing? Strain gauge. That's it. It uses a strain gauge, which measures how much something is bent in order to measure the torque. So it never strips because it's a non-moving part. Yep.
If you have problems with the torque wrench, at the school here they have a thing on the wall where they can check your torque wrench. You kind of like get inspection.
Is it a digital thing or is it a
No,
mechanical
it's
thing?
It's manual, so you can see if your torque wrench is working. So.
Yeah. The easiest way to check your torque wrench, is to have a pulley or a lever. Yeah. So you know the length of the arm, and you can hang a known weight at the end of the arm, and then use a torque wrench to try to move it. So that's an easy way to double check, and it cannot go wrong, right?
No, but they have something like that.
Yeah. Yep. But it's happening. Okay, your torque wrench, your hand tool is starting to have quote unquote computers inside. What is the next thing? A torque wrench that is Bluetooth enabled.
And a
I'm not
screwdriver.
kidding. I am not kidding. Okay, think of the possibilities. Okay, you're working in a noisy auto shop environment. Okay, people have to put on hearing protection, just so that they don't go deaf, at the end of the day. Okay, and you have a torque wrench, that beeps. Okay, you're gonna miss that beep. So what you do is you have a Bluetooth interface. Your torque wrench will talk to you through Bluetooth, with your big, huge, noise isolating, headset, and it will tell you have reached, 20 foot-pound, 25 foot-pound, 26 foot-pound. Yep.
What would it take to develop something like
Not a whole lot. Coming up with the idea is probably the hardest part.
that? No, I mean that's good what you're saying because like they have the Bluetooth, the code readers for the car.
Yep.
Same thing. So it's a good idea.
Yep.
So you can have like an impact gun, and then you don't even need the torque stick. You just set the torque on the impact gun. And
Potentially, yes. Yep.
That would be cool.
That would be cool. And it's going to happen. I mean, all of these things are going to happen. It's just a matter of time. And the limitation is not the technology. These chips, along with the sensors and other stuff, Bluetooth interface and whatnot, those are done. I mean, those are so done, they're mature technology already. The question is, how can you convince Snap-on, okay, or some of the other manufacturers to say, this is a good idea? And their objection is, now we have to hire engineers and programmers. Is that bad news for you guys or good news for you guys? Yep, you get more job opportunities. If you think about desktop applications, there are only so many applications that you can write on a desktop. All right, we'll move on to mobile devices, more apps, right? But there are only so many things you can do on a phone or a tablet. And then you expand from that point, you can expand on to torque wrenches, screwdrivers,
Home appliances.
home appliances. A lot of home appliances are now microcontroller based. It's just that some would advertise it as a feature, and some people do not want to advertise it as a feature because some people say, oh, that's too hard to use. Think about a toaster. Okay, when was toasters in the past, when they break, they tend to char or burn your toast, because the temperature control thing is just kind of like a mechanical thing. When it heats up, the bimetal thing just kind of bends, and it will automatically disengage the current. And you can have some, toastiness, control, but it's usually kind of vague, and and it varies from one toaster to the next. Okay, setting 3 on this toaster, maybe setting 2 on the next toaster, maybe setting 1 on the next toaster. It's really hard to make it consistent. If you make it controller based and you use reliable sensors, you can calibrate it before it leaves the factory. So instead of having 5 settings for toastiness, now you can have 500. I like my toast, at setting 263 and not 264. Okay, and it'll be consistent across, all the devices. You can leave some bread, on your toast, overnight, and then the next day it will turn itself on automatically, and stuff like that. And you can control it from your iPhone. Yes.
Well, you said we have mature microchips and everything, but the reason behind it is just really merchandise. People make money on that.
Well, the reason behind this has to do with manufacturing technology. Transistors are now smaller, so the yield is higher. In other words, the actual cost of these microcontrollers is very, very little. So as a result, and also there's a more demand. In other words, if only 500 people in the world will want to have something like this, it will be expensive, even if it is available. On the other hand, if Atmel can sell like millions upon millions of these things, the cost is going to go down, because every time they make one wafer, with this processor on it, they will sell everything in like 2 days, right? So that means they can keep running batches of manufacturing wafers with these things, and that lowers the cost of each unit. But it's really good news for everyone in this class, because if your objective is to become a software engineer or a programmer, this opens up all kinds of possibilities, because there's no operating system to say, oh, okay, you can only run this with Windows or Linux or Mac OS X. This has no operating system at all. Whatever code you write is whatever runs on it. So you have all the freedom to do whatever you want, but you also have the restriction of not having an operating system to help you with certain things. Okay, so this branch of programming is called embedded system programming, and I personally think, just looking at the past 20 years or so, I personally think that this is a one particular type of programming that will hire an increasing number of people, and knowing how to do embedded system programming, I think, is going to be helpful. So are there any questions about this sort of programming? No. No one seems to be interested.
Should we go to a class on
Sorry?
language? Should we go to a class on assembly language?
No. Interestingly, you can do most embedded system programs in C and C++. And that's why remember what Danny demonstrated. So what you want to do if you want to explore something like this is to look at Arduino. So look into Arduino, as a kit, and it comes with a programming interface, an IDE, which I kind of showed you guys earlier. And almost all the programs, all the code is in C and C++, and that's because there's a backend of G++ that compiles code for that particular processor. Not the 256 instruction one, but that family of processor can go all the way up to 256 kilobytes of program space. So that's a pretty good size. I used to teach a class over at UC Davis called Micro Mouse Design. I'm not sure how many of you know what a micro mouse is. No? Nobody? Okay, some people do. Okay. I can show you what a micro mouse looks like. I know I'm kind of digressing a little bit today, but I think it is important to kind of keep an eye on, different types of programming you can do. So we'll look at one that is coming from Davis. 2009. It's supposed to. That'll work. So basically, a micro mouse is a robot about the size of your palm, and it has to learn the configuration of a maze and go from one cell to the center of the entire maze autonomously. And the configuration of the maze is not made known to the robot ahead of time. So it has to learn, it has to map out the whole thing and try to figure out how to get to the center as quickly as possible at the same time. And it also has to control the motors, and so everything is. These students made the entire thing. Okay, they had to purchase the motors, but even the circuit board, they designed the circuit board themselves, and soldered the components, and wrote the entire program on these things. So you think about an application like this. How big do you think those programs are? Because I want to get to the size of a program. How much is 256 kilobytes? Because these days, we look at 256 kilobytes as nothing, right? I mean, what is the smallest program that you have installed recently? Probably measured in what, megabytes, right? So a quarter of a megabyte is a lot, because these programs, the one that has the largest program size is about 32 kilobytes. Okay, so 32 kilobytes of C code will get you a program that can run a robot, solve a maze, control all the motion, control all the read all the sensors, and optimize the path. And that can all be done in 32 kilobytes of object code. And the program is mostly, entirely, in some cases, written in C and C++. All right. So I think I just want to give you an idea of programming other than just, it's a program that runs on the desktop, on the server. Well, there are many different types of programming that I think is, one, interesting, and two, opens up all kinds of job opportunities. All right, so with that out of the way, are there any other questions regarding logical OR and logical AND? I'm hoping you guys are now getting back to the original topics that we were talking about. No questions? All right. If there are no questions, we are done with logical operations versus bitwise operations. I'm just quickly going through this to make sure I didn't miss anything. All right, so with that out of the way, we can now go on and kind of talk about integer types of C++. In addition to int as an integer type, what else can we do with integers in C++?
Assign them to variables.
Well, okay, so there's a base conversion thing, which is something that we talked about already. So I'm going to skip the base conversion. From base to the base 10, it's easier, actually, because you just have to add 1, 2, and then there are no 4, no 8. Here's a 16, and here's a 64. You just add them up, and you get the value in base 8. We already talked about integer width. Okay, the smallest or the most negative value with an integer is 2 to the power of negative 2 to the power of w minus 1, and w is the width of an integer. Now, this is something that is important, especially when you write a program that can potentially be compiled on different platforms. Okay, with the micro-mouse design projects, this is something that has happened. I encourage all my students to write their programs and test it not on the robot, but on the regular PC. That makes sense, right? I mean, you can run GDB, you have all kinds of tools to help you, and you don't need an actual robot to test the program. So they would write the program in GCC, in regular C, and use GCC to compile the program and test it and debug the program. But the moment they cross-compile the program to make it run on a robot, it stops working. And then they will be scratching their head. It's like, okay, but it's the same program. How can the program behave completely differently and erroneously when I move it onto a mobile platform? Well, one of the reasons has to do with, on a mobile platform, the integer size is changed. Instead of 32-bit, it becomes 16-bit. And some of the arithmetic operations involve integers that require more than 16 bits to represent the values, and that's why it runs okay on a regular PC, because on a regular PC, an integer is always 32-bit, but when you cross-compile, int, just using int itself as a type, becomes 16-bit, and it was not able to store the value that it needed to store. Yep.
It also matters what you use, right? It also matters where you shove the information into the 8-bit.
Well, it has to do with the implied width of an integer. Okay, we talked about this a little bit on Monday. The implied width of an integer depends on the target platform. So when you're dealing with a PC like these, the implied width is usually 32 or 64. But when you're cross-compiling to an AVR platform, it is only 16. And as a result, programs that need a wider integer would not work anymore because the width is now changed. So in C++, it's basically just the same. But what you want to do is to use these types instead of just int. There is a special include file or special header file that has the name of std standard int.h. once you include that particular include or header file, you can make use of the int names called int32 underscore t, int16 integer underscore t, and so on. So with these particular type names, this number indicates the width. So this way, if you take a program like this and you compile it to a different platform, it will still preserve the width of the integers. An int32 underscore t is always 32-bit wide, even if the target platform is smaller or bigger. int16 is always 16-bit wide. int8 is always 8-bit wide. So instead of using just the word int itself and then use short and long to kind of change what you think the width should be, it's always much better to use these particular types to spell out the width of the integers. Yep.
If that's the case, I mean, you're teaching this to us as you have like a real basic understanding of programming. Wouldn't your micromouse programmers already know this and should have written their coding in 16?
Well, apparently no one at UC Davis taught them that, even though they were the senior year. They're basically all seniors. They're about to graduate. The class that I taught was a final year engineering design class, so they're already in their 5th year because engineering takes 5 years to graduate, and apparently no one along those 5 years taught them about this stuff. So you guys have the benefit of me having taught those different classes and learned from experience bad things that you can run into if you do not explicitly state the width of your integers. But why would I write a program that can cross-compile onto different platforms? In other words, if I write a program in GCC, I just wanted to run on this particular PC. And this one has a 64-bit operating system installed, so my app only needs to run on a 64-bit platform. Why do I have to worry about 32-bit platform, 16-bit platform, and all of the other target platforms? Well, if you work for Microsoft, you may not have to worry. But if your application if your program is intended to work on different types of in different types of environments, then you have to worry about this. Yeah, you had your hand up. Go ahead.
Yeah, let's say you plug something into that computer that's not 64 or 32, then that becomes useful.
Right. Exactly. Yep. And as a programmer, you always should really know about the range of values that you want to store into these variables. See, with X here, you can store a value from about -2 billion to +2 billion. You should know your range, okay? With variable Y here, it can store approximately -32,000 to +32,000. With Z, it can only store values from about -100, well, exactly -128 to +127. But as a programmer, as a person who writes the program, you really need to know what is the required width by analyzing your program and say, okay, what is the range of this particular variable? Well, this one can only go from 0 to 20. Well, in that case, you can use any type. On the other hand, if you think, oh, this one can go from 1 to a billion, well, then you have to use a 32-bit because a 16-bit would not be able to represent the values that you want to represent. What if you have a situation where you have to count something and it can exceed 4 billion? Then you have to use int64 underscore t. You have to step up to the next available size, and the size or the width of these integers are always based on powers of 2. So after 32, it's 64. Okay. Are there any questions at this point about the different integer types? If there are no questions, we are done for today. So we are now up to, I just want to point out where we are at in the notes here. We are now done with integer types of C++. So the next topic we're going to talk about would be typecasting, coercion, and promotion. Okay, so you might want to read ahead of me a little bit. Sorry?
Roll sheet.
Roll sheet? go ahead and do the row sheet. I have to find a way to make it a distributive, row sheet, so I can pass out like multiple copies. But then I have to know who's going to sit where, to make it optimal. You know what? I'll just kind of take it back. Let's not take row today because we are already running out of time today. So I'll just kind of let it pass it. Assume everybody made it here today. So nobody's going to be marked as absent today. Don't worry. And I'll see you guys next Monday. Don't forget to read ahead of me because that is a kind of an important topic.